Multi-point cutting tool. Diagram, examples and advantages. A cutting tool is an implement with a wedge-like shape that shears off extra material from a preformed blank to produce the desired shape, size, and accuracy. It is the cutter's job to forcefully compress a thin layer of material within the workpiece, and then slowly shear it off as the operation proceeds. However, 3 relative motions are required to remove the material. In fact, these motions deliver the essential cutting velocity, feed velocity, and depth of cut. Since the cutting tool is firmly mounted on the machine tool's tool holder, it is unable to produce any such motion. Machine tools use a variety of arrangements to provide all required motions. Classification of cutting tools. Every cutting tool must contain a wedge-shaped portion with a sharp cutting edge, which can cut material smoothly, regardless of the operation it intends to perform. A cutting tool may have one or more primary cutting edges that engage in simultaneous cutting action in a single pass. Cutting tools can be categorized in a number of ways, but the most popular one is based on how many main cutting edges are actively engaged in cutting action at any given time. This allows for the division of cutting tools into the 3 groups that are listed below. Single-point cutting tool. Multi-point cutting tool. What is multi-point cutting tool? Multi-point cutting tool. It is common for multi-point cutting tools to have more than 2 main cutting edges that can engage in a cutting action simultaneously. Cutting tools with 2 cutting edges, rather than 2, can also be considered multi-point cutting tools, instead of double-point cutters. A multi-point cutter can have anywhere from 3 to hundreds of cutting edges. Due to the fact that the cutting edge appears at the intersection between the rake surface and the flank surface, each cutting edge has its own set of rake surfaces and flank surfaces attached to it. Nomenclature of multi-point cutting tool. Nomenclature of multi-point cutting tool. It is the milling cutter's main frame, on which the teeth are supported. It is referred to as the location of the cutter's tooth cutting edges. It is the part of the blade that comes into contact with the workpiece during the cutting process. It is the point where the teeth, face, and the tooth flank meet. It is the area where one tooth meets the face of another. It is used for supporting tooth cutting. Number 5. Face of teeth. It is the area where a chip forms during cutting. It could be flat or curved. Number 6. Back of tooth. It is produced by the secondary clearance angle and the fillet. It is the slender portion of the back of the cutting edge. The clearance angle produces land. The area between each set of teeth is referred to as the bottom land. Number 9. Root diameter. The diameter that connects the 2 ends of the periphery and passes through the cutter's center is known as the root diameter. Examples of multi-point cutting tool. The most specific example of this type of cutting tool is the milling cutter. The only exception is the fly milling cutter, which is a single point cutter. There are usually multiple point cutters available. Advantage of multi-point cutting tool. Chip load on each cutting edge significantly decreases because the total feed rate or depth of cut is divided equally across all cutting edges. In order to increase material removal rate and productivity, a higher feed rate or depth of cut can be used. The force acting on each cutting edge is significantly reduced as a result of the distribution of chip load. In some cases, a cutting force component gets eliminated or reduced automatically. 0 results for a particular cutting force component.